clear steps, making math easy to understand and fun to learn. So if you are ready to build your math skills the simple way, let's get started. Remember, solve it easy, solve it cool, and solve it simple. In this video, we are going to learn to solve the second exercise of chapter 6, lines and angles, that is exercise 6.2 of class 9 NCERT syllabus. The solution to the questions of exercise 6.2 are based on the concepts of parallel lines and transversal. Hope you are clear with these concepts. I have already created an introduction video explaining the concepts in detail. I recommend watching that video to reinforce the concepts before diving into the solution in this video. Let's start with the first question. Let's read the question first. In figure 6.23, if AB is parallel to CD and CD is parallel to EF and Y is to Z is equal to 3:7, find X. Let's first note down what is being given to us. It's being given that AB is parallel to CD, AB is parallel to CD and CD is parallel to EF and Y is to Z is equal to 3:7. Angle Y to angle Z is 3:7. You have to find X. You have learned in theorem 6.6, lines which are parallel to the same line are parallel to each other. So we know lines AB is parallel to CD and CD is parallel to EF. So as per this theorem, we can say that AB is parallel to EF as well. So as AB is parallel to EF, look at the angles which are formed here. So we can say that angle X and angle Z. What are the properties of these angles? These two are alternate interior angles. You have a look at the angles. X is interior to AB and Z is interior as well to EF. So these two are alternate interior angles, and so we can say that angle X is equal to angle Z. Angles X is equal to angle Z. Reason is alternate interior angles are equal. Angle Z is equal to angle X as alternate interior angles are equal. Now look at the angles again, and can you figure out anything else? So same thing, like CD is parallel to EF. We see one angle Y here. Can you find another angle corresponding to this? You can see that angle Y is equal to the angle here. Let's name this angle as A. So we can write angle Y is equal to angle A. Why? Because these two are corresponding angles. Corresponding angles are equal. Angles are equal. Angle Y is equal to angle A as corresponding angles are equal. Now it's been given Y is to Z is 3:7. So we can write, can consider that Y is to Z is equal to 3:7. So let's consider that Y is equal to 3x. Let's take it as capital X because we have to find out small x. Y is equal to 3x, Z is equal to 7x. So 7x. And look at these angles A and Z. Now we can see that these two forms a linear pair, right? Angle A and angle Z. So we can write angle A plus angle Z is equal to 180 degree. Why? Because these are linear pair. And instead of angle A, we can write angle Y plus, let's write it as angle Z itself now. It's 180 degree. Why we wrote like this? Because we have a ratio Y and Z here. So instead of angle Y, we can write 3x plus angle Z is equal to 7x, which gives you 180 degree, or 10x is equal to 180 degree, x is equal to 18 degree. So we have x is equal to 18 degree. Now substitute the value of x here for y and z. It's been given y is equal to 3x, which is equal to 3 into 18, which is equal to 54 degree, and z is equal to 7x, which is equal to 7 into 18, which gives you 126 degree. But we know angle x is equal to angle z. So instead of z, we can write angle x is equal to 126 degree. So we have to find out x. So the value of x is equal to 126 degree, which is our answer. Let's solve the second question now. Let's read the question first. In figure 6.24, if AB is parallel to CD, EF perpendicular to CD and angle GED equals 126 degree, find angle AGE, angle GEF and angle FGE. Let's note down what's been given to us. It's given that AB is parallel to CD, EF is perpendicular to CD and GED is given as 126 degree. We have to find angle AGE, GEF and FGE. So as given, GED is given as 126 degree. Let's mark that first. GED, which is GED, this is GED, which is given as 126 degree. You see this is EF is perpendicular to CD. So angle E or FED is given as 90 degree. So we can write it as angle GEF plus 90 degree is equal to 126 degree. GEF, this angle, plus 90 degree will give you 126 degree. Or we can say angle GEF is equal to 126 minus 90, which will give you 36 degree. So angle GEF is given as we have found out as 36 degree. So we will mark that 36 degree here. GEF is 36 degree. Now you see this AB and CD and the transversal line GE. So we can see here AB, parallel line AB, CD and the transversal GE. So what can you infer from here? You can see that this 126, this angle and this angle are alternate interior angles, and we know alternate interior angles are equal. So this angle and this angle are equal. How do you find? Because this is a transversal, we have alternate angles which interior angles which are alternate, which are equal. So this GED, this 126 degree, this also will be 126 degree, which is that AGE. So we have found out AGE also, which is 126 degree. So we can write angle AGE is equal to angle GED, which is equal to 126 degree. So angle AGE is equal to 126 degree. So we have found out AGE as well. AGE is 126 degree because these two are equal, because alternate interior angles are equal. Alternating interior angles are equal. AGE is given as AGE we found out as 126 degree. Now look at the figure again. So you can see that this angle and this angle forms a linear pair. Why? Because these two angle forms a straight angle. So we can say angle AGE and FGE is equal to that. Sum of these two will be 180 degree. So we can write angle AGE angle AGE plus FGE, angle FGE. FG is 180 degree. Why? Because those are linear pair. And we know AGE is 126. So angle, this we write it as 126 degree plus angle FGE is equal to 180, or angle FGE is equal to 180 minus 126, which will give you 54 degree. So we found out FGE as well. FG is 54, AG is 126, and GF is equal to 36. Please note that these questions can be solved in different ways depending on which angle you are taking and which properties of transversal and parallel lines you are taking. So the way that you approach the questions may be different, but as long as you apply the concepts, apply the properties correctly, that is fine, and you get the answers the same way as well. Now let's solve the third question. Let's read the question first. In figure 6.25, if PQ is parallel to ST, angle PQR is 110 degree and angle RST equals 130 degree, find angle QRS. Hint is given as draw a line parallel to ST through point R. Now let's note down what is being given to us. It's given PQ is parallel to ST. PQ is parallel to ST. Angle PQR. Angle PQR is 110 degree. RST is 130 degree. RST is 130 degree. And we are asked to find QRS. Angle QRS. And it's given that as a hint, draw a line parallel to ST. Draw a line parallel to ST through point R. Let's draw a parallel line parallel to ST through R. So let's draw a parallel line. Through R. So let's extend them. And it is R, and let's name them E, F. You can name them name it as you like. So we just draw this R. Okay. Point the R. Whatever is given, we will write down here. PQ is parallel to ST, which is given. And we have EF drawn parallel to ST. So EF parallel to ST, that is by construction. So we constructed the line as per the clue that is being given to us. And now we can say that PQ is parallel to EF as well. Why? Because of the theorem 6.2. PQ is parallel to EF as well, because as per the theorem 6.6, right? And now let's find out QRS. QRS. Let's apply the properties of parallel lines and transversal. How can you find them? You see this angle, we have two parallel lines, PQ and ER, or PQ and EF. Consider that line. And we have two parallel lines cut by a transversal. And we have one angle 110 degree. So what would be this angle? And how do you find them? So we see that these two are angles on the same side of the transversal. Parallel line, transversal, two angles on the same side of the transversal. Or we say this angle is, these two angles are co-interior angles. So what would be the value of that angle? It would be 70. How do you find them? Because co-interior angles are supplementary. You know, angle PQR plus angle QRE is 180 degree. Why? Because co-interior angles are supplementary. You know how you got them, right? Are supplementary. So we know PQR, which is 110 degree, and then QRE is what you have to find out. QRE is what you have to find out is 180. So QRE will be 180 minus 110, which would be 70 degree. You don't have to write all this if you know directly from the diagram. So you can just point out, just write it down over there itself. No need to do this if you know that. But we make sure you write this so that you state why we got this QRE as 70 degree. Okay. Now we have another angle given, 130 degree, and we have two parallel lines, ST and EF. Consider ST and EF. Is there any relation between these two angles? We have one interior angle here, which is given as 130 degree. What about these two parallel lines, ST and EF, and the transversal? Can you say that this and this angle are alternate interior angles? Let's mark them. This is 130 degree, which is one angle, and this angle is also 130 degree, because these two are, see, this is a parallel line, we have a transversal, alternate interior angles. So alternate interior angles are equal. So we know this angle 70 and this angle we have to find out, and this together will be 130 degrees. Very easy. 70 plus what makes 130? That is your answer, which is 70 plus 60 will be 130. So this angle will be 60 degree. Let's write down that also. Now we can write angle ERQ plus angle QRS is equal to angle RST or TSR. Why? Because alternate interior angles are equal. I wrote it as a short form. You can write it out as a full name. Full form, alternate interior angles are equal. So we write, we know ERQ is 70 degree. So 70 degree plus angle QRS is equal to angle RST. RST value is 130 degree. Therefore angle QRS is equal to 130 minus 70 degree, which is equal to 60 degree, which is our angle. So angle QRS is equal to 60 degree. Please note that you can solve the same questions in different ways. You can also see that using this as a co-interior angles and then find this. Depends on how you approach the question. Hope it's clear to you. If it's not clear, please go through the questions again, go through the solution again, and then reinforce the concept. Let's read the question first. In figure 6.26, if AB is parallel to CD, angle APQ equals 50 degree and angle PRD equals 127 degree, find X and Y. Let's note down what is being given to us. It's given AB is parallel to CD, APQ equals 50 degree, PRD equals 127 degree. We have to find angle X and Y. How do you find them? You see, we consider lines A, B and CD first, and then the line transversal PQ. AB parallel to CD cut by the transversal PQ. What is this 50 degree? 50 degree is an interior angles. What could be the alternate interior angles? It will be X, right? So we know alternate interior angles are equal. So these two are equal, or we can say X is equal to 50 degree. Let's write down that. We can say that angle APQ, let's write down that it is 50 degree. APQ is 50 degree. Angle APQ is equal to angle PQR. Y alternate interior angle. I just write down the short form, you have to fill it up fully. Alternate interior angles are equal. So we write APQ is 50. So APQ is 50, x is equal, which is equal to x, angle x, which is, so x is equal to angle 50 degree. Sorry, x is equal to 50 degree. So we found x as 50 degree. Now let's consider lines AB and CD again with the transversal PR. AB and only PR. Okay, so AB and PR. So what is that? We have an angle 127, which is an interior angle. What could be the alternate interior angle to 127? When you ignore the line PQ now and just consider only PR. PR 127 is one of the angle. The alternate interior angle for this would be this angle, right? Which is alternate interior angle for 127 will be this angle. So what is the value of this angle? Value of this angle is 50 plus this angle. So we can write 50, or we can write angle PRD is equal to angle APQ plus angle QPR. You don't have to write this if you know it directly from there, or you can write like this: 50 degree plus Y is equal to 127 degree. This is enough. Just write down so that you can explain why this we have written down. Alternate interior angles. I just write down alternate interior angles are equal. You can omit this and write this one as well. So what is Y? Y is 127 minus 50 degree, which will give you 77 degree. So that is the answer for Y. Y will be 77 degree. So we write Y as 77 degree. So very easy. You can just find out the answer from the diagram itself. Let's solve the last question now. Let's read the question first. In figure 6.27, PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC and strikes the mirror RS at C, and again reflects back along CD. Prove that AB is parallel to CD. Let's understand the question first. It's been given that PQ and RS are two mirrors placed parallel to each other. So it means that PQ is parallel to RS. PQ and RS, two mirrors placed parallel to each other, means PQ is parallel to RS. And it's given now an incident ray AB strikes the mirror at point B. AB, incident ray AB strikes the point at B, and then it is reflected. That means forming the ray BC, and that BC strikes the mirror RS again at point C, which is reflected again, forming the ray CD. Now we have to prove AB is parallel to CD. AB is parallel to CD. Now for proving AB to CD, AB is parallel to CD, we can use the properties of parallel lines and the transversal. We can see two parallel lines and the transversal here. So for that, if we can prove that these angles are equal, that means the alternate interior, you see this angle here, angles, if these two angles are equal, we can prove that AB is parallel to CD. To solve the question, first let's look at the concept of incident ray and reflected ray. You have learned in your physics class about angle of incidence and angle of reflection. What is an angle of incidence? If we have a ray which is hitting a surface, and when it is reflected back, there are two angles which are formed. One is the angle of incidence and the other one is the angle of reflection. What is angle of incidence? Angle of incidence is the angle at which a ray of light hits a surface, and it is the angle between the ray and the normal. So this is a normal. What is a normal? Normal is a line perpendicular to the surface, and the point of incidence. So if you have a ray of light striking or hitting the surface and then it is reflected, we have two angles which are formed. One is the angle of incidence and the other one is the angle of reflection, angle I and angle R. Angle of reflection is the angle between the normal and the reflected ray. So these two are the angle of incidence. So we have two angles, angle of incidence and angle of reflection. So if we have the same angle here, incident ray here, and forming two angles, angle of incidence and angle of reflection. So we call this angle of incidence. Let's name this as angle 1 and this as angle 2. So we have ray of light, ray AB striking mirror at B and then reflected. So we have an incident ray and a reflected ray forming angle of incidence and angle of reflection. So we call the angle of incidence as 1 and this as 2. Similarly, we have again this ray striking the mirror at point C. So again we have a normal here. So this is the same normal we have drawn here, normal here, and then we have again an angle of incidence. This is the angle of incidence here and angle of reflection here. So let's name this angle as 3 and this as angle 4. And also you have learned in the law of reflection, you have learned that angle of incidence is equal to angle of reflection. Law of reflection states that the angle of incidence is equal to angle of reflection. So we can say that angle 1 is equal to angle 2, and we can also say angle 3 is equal to angle 4. Did you understand the concept? The same normal is the same normal here. The ray, incident ray and the reflected ray. The reflected ray is again considered as the incident ray here and then reflected. So angle 1, angle 2, angle 3 and angle 4 are formed, which are angle of incidence and angle of reflection. So angle 1 is equal to angle 2, angle 3 is equal to angle 4. So as per the law of reflection, we can write that angle 1 is equal to angle 2, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Let's name this as equation 1 and this as equation 2. And why we wrote this? This is because of the law of reflection. As per the law of reflection, angle of incidence is equal to angle of incidence is equal to angle of reflection. We can state this as a reason. So we have angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Now let's look at the figure. We have two lines BL. We have two lines here, which is a perpendicular line to PQ and the perpendicular line to RS. So let's name it as BL and this as CM. So BL is a perpendicular line to mirror PQ or parallel line PQ, and CM is a perpendicular line to RS. This is a normal line between the angle of incidence and the angle of reflection, right? We have already found how we got that. angle, normal line or a line perpendicular. So BL and CM. Look at these two lines. Are these two parallel? Yes. We can state these two are parallel because we have already studied in a fact that lines perpendicular to parallel lines are parallel. So we can say that these two lines BL, which is perpendicular to PQ, and CM, which is perpendicular to RS, are parallel. So what can we say? We can say that BL is parallel to CM. BL is parallel to CM. Let's redraw this so that we'll understand it more clearly. So we say BL is parallel to CM. This is the BL and CM. So we draw BL here and CM, C and M. And then we draw the transversal, which is a transversal BC. And we also have this angle here, 2 and 3. Clear? BL is the parallel line to CM, and we have the transversal BC, and we have angle 2 and angle 3. We have stated that BL is parallel to CM. So what can we say about these two angles? Angle 2 and angle 3. Yes, angle 2 and angle 3 are interior angles, which are alternate interior angles. And we have learned two parallel lines intersected, cut by a transversal, alternate interior angles are equal. So what can we say? We can say that angle 2 is equal to angle 3. Did you understand how we got that? This angle 2 and angle 3 are alternate interior angles to parallel lines BL and CM. BL and CM cut by transversal BC. Angle 2 and angle 3 are alternate interior angles. So angle 2 is equal to angle 3. So what we do now? We will add these 1 and 2. Adding 1 and 2, what will happen now? We can write angle 1 plus angle 3 is equal to angle 2 plus angle 4. Angle 1 is equal to angle 2 and angle 3 is equal to angle 4. These are the two equations. We add them up. Angle 1 plus angle 3 is equal to angle 2 plus angle 4. But we have found that angle 2 is equal to angle 3. So instead of angle 3, we can write angle 2 itself, right? Because those two are equal. So we can write angle 1 plus angle 2 is equal to, instead of angle 2, we can write angle 3. This is the same, right? Angle 1 plus angle 2. Why angle 2 instead of angle 3? Because we have found out that BL is parallel to CM and these two are alternate interior angles which are equal. So instead of angle 2, we wrote, instead of angle 3, we wrote angle 2. So angle 1 plus angle 2 is equal to angle 3 plus angle 4. So now let's look at the figure. What is angle 1 plus angle 2? Angle 1 plus angle 2 is this angle. What is that angle? ABC. Can you see that? Angle 1 plus angle 2 is this angle, which is that angle ABC. So we can write this as angle ABC is equal to, what is 3 plus 4? Angle 3 plus angle 4. We can say that is as BCD. Angle BCD. Clear? ABC and BCD. This angle. So what are those two angles now? Just redraw these lines here. AB and CD cut by this transversal BC. So now we have found out that ABC angle. That means this angle is equal to this angle. So what does that mean? These two are interior angles of a so-called parallel line. So these two are, we proved that these two are equal. So that means that AB and CD will be parallel lines. So as we say that angle ABC is equal to BCD, we can say that AB is parallel to CD. Clear? These two are alternate interior angles. So we should say write it here. These two are, the reason is alternate interior angles. Also here, alternate interior angles are equal. Okay, you write the reason why we stated angle 2 is equal to angle 3. Here also we write alternate interior angles are equal. Clear? So this is how we get the answer. Let's look at the solution once more so that it is clear to you. It was given that PQ is parallel to RS. Two mirrors placed parallel to each other. That means PQ is parallel to ERS. So PQ is parallel to RS, and we have an incident ray and a reflected ray, and a ray incident again on this surface RS and then reflected. So incident ray and the reflected ray forms two angles, which are the angle of incidence and angle of reflection. So angle 1 and angle 2 are the angle of incidence and angle of reflection. Similarly, we had angle of incidence here and angle of reflection. And as per the law of reflection, we can say angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Angle of incidence is equal to angle of reflection. It's the same one here for this as well. So we found these two out, and then we know that we have got these two lines BL and CM. These two are the normal line perpendicular to PQ and RS. These are the the line which is formed between the angle of incidence and the angle of reflection. So we know that BL is parallel to CM. As these two are perpendicular to the parallel lines, these two are parallel as well. So we found BL is parallel to CM, and as BL is parallel to CM and we found these two angles are alternate interior angles, so we wrote angle 2 is equal to angle 3. Alternate interior angles are equal. Clear? BL is parallel to CM, angle 2 is equal to angle 3. Now we add 1 and 2, that is angle 1 plus angle equation 1 and equation 2. Then we got angle 1 plus angle 3 on the left hand side, and RHS is angle 2 and angle 4. So we added angle 1 and 3, angle 2 and angle 4. As we found that angle 2 is equal to angle 3, instead of this 3 we replaced it with 2. So it became angle 1 plus angle 2 is equal to angle 3 plus angle 4. And from the figure we know angle 1 plus angle 2 is angle B or ABC. This is an angle B, that is ABC, and angle 3 plus angle 4 is this angle C, or we write BCD. ABC is equal to BCD. As we found that these two angles are equal and these two are the alternate interior angles, we can say that AB is parallel to CD. That's how we wrote this. The reason for AB parallel to CD is alternate interior angles are equal. This is how we solve this question. So if you have any doubt, still go through the solution once more and we'll be able to solve it. By this we have come to the end of the video. Hope you have understood how the questions are solved. Try practicing to solve more questions and enjoy learning. See you in the next video. Till then, take care and bye.